So I have the great pleasure of introducing our next speaker. Her name is Aline Guillermet, and she's a college teaching officer at King's College, Cambridge. Welcome, Aline.
Thank you, Leah, for the invitation and the introduction. Okay, so just as a sort of introduction, I wanted to say that my primary research is on digital arts, but this project has led me to issues that are connected to the digital humanities and digital art history in particular. So this is what I'm going to be trying, these two realms that I'm going to be bringing together in this paper. So the paper makes an attempt to connect recent artistic appropriations of technologies that quantify perception with the field of digital art history. I will argue that digital art can provide a novel perspective on current uses of gaze tracking and pattern recognition technologies in art history. One of the questions that arises from recent developments of digital art history as a discipline has been the following. Is it possible to quantify and model aesthetic perception? This question has been brought from two different but complementary points of view. The first one consists in studying human perception of artworks through gaze tracking. So for instance, and this is an example amongst many, an interdisciplinary study carried by the Laboratory for Cognitive Research in Art History at the University of Vienna by Raphael Rosenberg and Christoph Klein has used gaze tracking to quantify and model subjective responses to two paintings. And the two paintings are, one of which is this Joseph-Marie Wien Saint-Denis preaching in Gaul. And the study aimed at verifying a series of hypotheses that had been put forward by the French art critic Denis Diderot in the 18th century, which had to do with beholders' perception of patterns in paintings. And specifically, Diderot had identified in Wien's painting what he calls a line of liaison, a ligne de liaison in French, which is an objective formal feature in the work that actually guides the perception of the viewer. So Diderot is making a link between the formal aspect of the work and the way this is going to influence aesthetic perception. And as you can see in the two figures, figure 2 and 3, the study of Rosenberg and Klein recorded and mapped the gaze movement of viewers on the same painting with, of course, quite different technological means to Diderot. And in the middle, it's the gaze patterns of one viewer, and to the right, a sort of means trajectory of gaze pattern of 40 viewers. And what they found is that although Diderot had not been accurate in evaluating the complex dynamic of fixation and saccades of the gaze, because he didn't have the means to, the hypothesis of the line of liaison was actually very accurate. And this is the sort of line you can see in the third image to the right, which basically was confirmed by the experimental studies that Rosenberg and Klein conducted. So that's for the first approach. Now the second approach is the quantifying of aesthetic perception according to a sort of, from an opposite perspective. So instead of going from the human perspective, this perspective automates perception processes, and this is sometimes called computer vision or pattern recognitions or image, computational image analysis. And this approach can potentially generate new ways of seeing that could not be perceived by the human eye. And here I'll quote again just one study which was conducted, in fact, by Leo here, Leo Impet and Franco Moretti, and which applied computer vision to Abi Warburg's Atlas Mnemosyne. So the German art historian Abi Warburg had coined the term pathos formen, translated in English to expressions of pathos or formulas of pathos, to describe a specific form of dramatic expression which he had observed in artwork throughout history. And one example that he took is the flowing hair of Botticelli's central figure in The Birth of Venus, which you can see portrayed at the top of his panel here and also, of course, to the right. And one thing that I'm interested in is what happens before the actual quantification process. And when Impet and Moretti set out to transform Warburg's concept of pathos formen, what they were interested in is to transform this concept into a series of quantifiable operations, thus turning it into an instrument to actually measure the objects it refers to. So this is a quote from their paper. So I'll return to this study in the second part of my paper. Where gaze tracking considered aesthetic perception primarily as a human activity that can be quantified, computer vision automatizes human perception itself. The second approach has a range of implications for digital art history and beyond, as I'll argue. My focus, however, is not going to be on digital art history itself, but rather, as I mentioned at the beginning, on artistic practices that use similar technologies of gaze tracking and computer vision in order to reflect upon the quantification of perception. So I'll begin by focusing on gaze tracking. And just a brief contextualization of this technology. Gaze tracking technologies have been around for quite a long time. They were originally developed in the context of experimental psychology. And the first scholar to apply these technologies to the viewing of artworks was the psychologist Guy Thomas Buswell, and especially in this landmark book of 1935, How People Look at Pictures. And this was the first study to reveal the complex and unconscious gaze movements that take place when viewers are looking at paintings. And of course at other things, but in this case, the experiments were exclusively done on paintings. Buswell conducted experiments with 200 people. And as you can see on the right, he plotted each set of responses to a set of paintings. And his major contribution was to identify what he called recurrent areas of interest in each paintings, which are these points where the viewer's gaze has repeatedly returned. And he was able to show that there was some consistency in how different viewers looked at the paintings through these areas of interest, through these findings. Buswell, however, remained cautious of interpreting these results qualitatively, and unlike Diderot, refused to draw any link between his experimental findings at a formal level and anything like an aesthetic appreciation of the paintings. And a review of the study published in the Burlington magazine at the time concluded, quote, "Nothing of the slightest importance to the science of aesthetics or psychology seems to result from this research," end of quote. So the question of the interpretation of gaze tracking results is central to the work of the first artist I'm going to be talking about, the Swedish artist Jonas Lund. In 2013, Lund created the installation Gallery Analytics for the exhibition Momentum in The Hague. And this is the image to the left. The installation is composed of a Wi-Fi network, which combined with custom-made software, track every Wi-Fi enabled device moving around the exhibition space in real time. The data gathered in this manner reveals how many visitors were in the gallery at any point in time, and also how much time people spent in front of each work. The question this work raised was that of the significance, aesthetic or otherwise, of such data that can be gathered in this way. And as Lund put it himself, quote, "What can it mean that a visitor spends more time in front of a specific work?" End of quote. In VIP, Viewer Improved Painting, which is the work to the right, made 1 year later, Lund brings this question to bear on the perception of a self-improving digital painting. VIP, as you can see, is composed of 2 screens hung side by side, and in the middle is a gaze tracking camera that captures the gaze of the viewers. As the title indicates, the painting's formal appearance is supposed to become improved through the viewer's eye movements recorded by the camera and subsequently treated by an algorithm that reconfigures the patterns on the screen. At the start, as you can see, the screens are fairly monochromatic. In fact, they are fully monochromatic at the beginning, and this is already a sort of variation. But the formal appearance complexifies as the data gathered by the camera is treated, and you can see what happens after a while in this installation view. From a monochrome, VIP gradually evolves to become a digital color field made up of day-glow pink, green, purple, and yellow and blue. The changes in the color patterns are the result of a selection process called A/B testing. So this means that if the viewer looks at the screen on the left, the algorithm will take into account this preference and then delete the version that was at the time on the screen on the right from its database. And then it gets gradually sort of narrowed down in this way, and vice versa, of course. Unlike Rosenberg and Klein's study mentioned above, the technology used in VIP is pretty basic. It doesn't permit the recording of the gaze pattern on the screen. So for example, it doesn't permit to identify areas of interest within the screen itself. And in addition, the binary logic of the A/B testing means that the viewer's preferences are not taken into account in real time. So it's not the case that you might be looking at a certain screen and then the other one would change in response to that. What VIP and gallery analytics do achieve is to raise questions with regards to the methodological choices that inform studies in the quantification of perception. Lund writes that he designed gallery analytics, so the first of the 2 works, as a critique of customer tracking in shopping centers. So these tracking mechanisms monitor the customer's trajectories and quantify the amount of time that people spend in front of specific display windows in the shopping centers. Underlying these marketing studies is the assumption that the length of attention can be connected to something meaningful, such as, in this instance, sales figures, of course. Lund's works challenge this methodological assumption by transposing this technology in the artistic realm. VIP takes this critique further even by suggesting that viewers' fixation patterns can be equated with aesthetic pleasure. So these 2 examples show that in order to become meaningful for the consideration of painting, gaze tracking technologies must first of all identify a conceptual framework relevant to aesthetic perception. I now move to the second part of this talk, which is a consideration of computer vision. Metaphorically called computer vision, the computational analysis of images relies on pattern recognition and machine learning in order to, quote unquote, see an image. In the history of art, its applications range from the formal analysis of individual artworks to the comparison and classification of motifs across a larger corpus. For instance, computer vision has enabled art historians to automate existing analog processes, thereby expanding studies to a larger corpora of images. And as Joanna Drucker, the media theorist Joanna Drucker has noted, this can yield radically different effects to what was previously possible. And this indicates that the change in scale can in some cases produce a qualitative change in the research results. So a shift from the quantitative to the qualitative. In the second section, I want to point to two challenges that arise with visual pattern recognition in the context of the history of art. And I'll look at the first one through an artwork by the artist Erica Scourti, which has, and this first challenge has to do with the programming and machine learning that informs pattern recognition, so before the actual quantification process. And the second challenge, which I look at through an artwork by Toby Ziegler, has to do with what happens after the quantification, so with the interpretation of the classification that happens from pattern recognition. So my first example is Erica Scourti's Soul IQ, which presents a series of personal snapshots to pattern recognition and auto-tagging softwares. In an eponymous article, Scourti discusses a specific photograph, which you can see here, which represents two young women smiling, and which were tagged with the following words by the software. So there's quite a lot, but I'll just pick out a few. Person, human, happy, pretty, attractive, and cute. Where the first two words, person and human, indicate a process of formal recognition, the rest of the series implies value judgments. And these, as Scourti suggests, reveal more about the machine learning process of the algorithm itself than about the image content. And the artist says in this article, quote, "Any claims to objectivity are undermined by the reliance on culturally assigned presets for what emotions like happiness or sadness look like, and by the unspoken assumption of a default subject who is most likely to be white and male." Similarly, auto-tagging software that algorithmically parses images into descriptive keywords betrays the sexism of the people who devised its taxonomy. End of quote. So of course, digital art history is very aware of this first methodological challenge of what happens before at the level of programming. And here I'll go back to the study that I mentioned earlier by Impet and Moretti, the study of the Warburg's pathos formen. And the authors write, quote, "Before any counting begins, you must really analyze the concept, take it apart and consider the value of its various elements," end of quote. And in response to this conceptual analysis, the author identified that the expression of pathos, identified by Warburg, resides primarily in the representation of the body's attitudes and movements, as opposed to, for instance, the face. And following this, they conceived of the quantification according to three methodological principles. The first one was to remove the human figures from the original contexts. The second one was to reduce their bodies to skeletons, and you can see this reduction above each image here. And the third one was to measure only one variable, namely the angles formed by the body's joints, now outlined by vectors. So the second methodological challenge alluded to above, that of the interpretation of the results, remains a main difficulty of digital art history and is closely connected to the first one. And the study of pathos formen is the link to the second challenge. Because the authors had expected that their tool would identify and isolate all pathos formen from other forms of expression, which the algorithm did. But they had also anticipated that the algorithm would separate different forms of pathos formen into groups. That the algorithm, that is to say, would be able to see a difference between the kind of images that you can see below. So for instance, between the agonizing priest at the center of the Laocoon group here and the Judas maid carrying the head of Holofernes here. obviously representing quite different emotional states. But surprisingly, this was not the case. And the authors wrote in response to this, quote, clearly the algorithm had, quote unquote, seen a similarity among the pathos form and skeleton vectors, which seemed to consist in this. Pathos formen were all correlated to a simultaneous movement of both arms and legs. This was the shared morphological feature around which the algorithm had clustered pathos formen together. End of quote. We might argue that the algorithm had merely done what it was told to do, namely to focus on the position of the figure's arms and legs. But more fundamentally, this study's unexpected result raises the problem of the work of interpretation that must necessarily follow quantification processes. And in this respect, the authors of the study concede that they remain uncertain as to, quote, the anthropological and or aesthetic meaning of this algorithmic way of seeing Warburg's pathos formen, end of quote. This prudence echoes Buswell's, who, as we saw at the beginning of the talk, had also refrained from drawing any aesthetic conclusions from his gaze tracking studies. And this points to an important issue. On the one hand, the question of how to interpret the measures is left open, indicating that bridging the gap between the quantitative and the qualitative, between the quantitative analysis and its potential meaning, in other words, can be difficult. On the other hand, it's clear from the studies that the automatization of vision calls for a critical work of interpretation to gain its full significance. The importance of critical interpretation in the context of automated patterns recognition is something that's central to the work of the last artist that I will present, Toby Ziegler, and I will focus, sorry, this is not actually his work, but I will focus on a video called Visual Genome of 2019. And what you see here is a set of images from the tool that this video appropriates. And this is a tool also called Visual Genome, confusingly. It's a data set that connects computational image analysis with linguistic descriptors, as you can see here. And this tool was designed by a group of students, postgraduate students of Stanford University. And really the sort of novelty in the image analysis is that it doesn't only sort of tag parts of the image, but it reads connections, structural connections in a given image. So you can see this with the keywords here in green, like sit on in front of sit on. Now, Ziegler's video is using this tool, as I said, and is composed of a succession of images in the process of being analyzed by Visual Genome. You have an example on the left here of a straightforward case. I won't comment on the images because that's a whole other topic. Dogs on pizza. So the algorithm has detected dogs on pizza. But some of the linguistic descriptors stand out, and some of them, for example, pastry is breakfast, this photo is great, or here on the screen, this photo was taken in Boise. And these comments or these sort of subtitles seem to be less close to linguistic descriptors and closer to personal comments or value judgments. They're not particularly objective, in other words. And these have been actually added by the artist. They're not generated by the Visual Genome tool. And of course, what's interesting is that this has the effect of blurring the boundaries between the quantitative analysis and an interpretation of the image, but sort of putting the interpretation in the mouth of the algorithm, so to speak. From an art historian's perspective, this tongue-in-cheek manipulation of automated pattern recognition and their description functions as a note of caution. namely that we ought to treat any conclusions generated by computer vision very carefully. So briefly to conclude on this paper, I suggested that the work of 3 digital artists, Lund, Scourti, and Ziegler, provide a new lens to consider the methodological challenges that quantifying perception presents for artistry. Developed between techno-science and science fiction, these artworks use similar technologies to those in use in digital artistry, yet often seek to reposition the human subject at the center of their critical discourse. Despite the recent developments in gaze tracking and computer vision, these technologies often fail to account for more qualitative dimensions of perceptions, such as the aesthetic. And if we can draw a lesson from Lund, Scourti, and Ziegler's work, it might be that this temporary shortcoming is not such a bad thing after all. Thank you.